This example comes out of section 8.1, Understanding Logarithms. Alright, so in this example, we're talking about the Richter scale. Most of you have probably heard of the Richter scale. It measures earthquakes, and you'll be given an equation that goes with it. If you're ever asked a Richter scale question, you don't need to start trying to memorize what the Richter scale is or what the equation is for it. So we're given here m equals log of a over a0, and we're told that a is the amplitude of the ground motion of our earthquake that we're looking at. They measure these waves with these machines, and again, this isn't a geology class, so you don't need to know all those details, but a0 is the amplitude of what's called the standard earthquake, basically a tiny little vibration, and m is the magnitude on the Richter scale. So if somebody says that earthquake was a 5.2 on the Richter scale, that's the magnitude. So our first example is about an earthquake that actually happened in Vancouver a little bit before your time and a little bit before my time in 1946. So we're given some information about this earthquake, and we're told that it was 10 to the 7.3 times as large as A0, meaning that it was, over 10 million times the amplitude of this standard earthquake I was talking about. And the question is, how big was its magnitude on the Richter scale? Well, if I just use the formula, m equals log of, and I substitute in 10 to the 7.3 times A0 divided by A0, you'll see why the magnitude of that, or the amplitude of that A0 is not really that important, because it cancels out anyway. And we get just an answer that's going to be log of 10 to the 7.3. And you can punch that into your calculator if you want to, but log base 10 of 10 to the 7.3 equals 7.3. And so something that has that much amplitude, that's 10 to the 7.3 times A0, is a 7.3 on the Richter scale. Now the second example talks about an earthquake a few years later that was even a little bit bigger. So what we're asked here is, we're told that this earthquake in 1949 was an 8.1 on the Richter scale, and again measured in BC somewhere off the coast, and apparently one of the strongest, if not the strongest, ever measured in Canada. How much stronger was it than the 1946 earthquake? Well, if you've already done the question previous, you'll know that the 7.3 on the Richter scale meant that you were 10 to the 7.3 times as big as A0. That's the amplitude. Even if you hadn't done the question previous, you could plug the numbers into the formula up above and get to this point. If we do the same thing for the 8.1 on the Richter scale, it means that it's 10 to the 8.1 times as big as that A0. That's the amplitude of this one. So if I take the larger one, the 8.1 amplitude, and divide it by the 7.3 amplitude, I'm going to have something that looks like this: 10 to the 8.1 over 10 to the 7.3. Same base, so I can subtract the exponents, so it gives me 10 to the 0.8, and 10 to the 0.8, if you try that on the calculator, gives you a number that's just a little bit more than 6. It's about 6.3 times as intense as the earlier earthquake. So it's even though it seems like it's just a little tick above on the Richter scale, each one unit on the Richter scale actually turns into a factor of 10. So in this case, it was 0.8 units higher on the Richter scale. 10 to the 0.8 gives us 6.3 times as intense.